Thank you so much. So yeah, first I want to offer a perspective, an unpopular one, about the way that blockchains track user bases and how they treat those user bases. Because I think when, with the Bitcoin white paper kind of came this staple belief of don't trust, verify. And I'm sure that you've kind of heard this iterated before, not just in Bitcoin communities, but in all communities. And what it means is all harm done in blockchain is self-harm by definition, because it assumes that every user knows how to use elliptic curve cryptography and every user has sufficient knowledge to audit every smart contract they interact with, for example. Like, this is the ethos of blockchains, which is that no one can do to you anything that you haven't done to yourself by not taking seriously your own responsibility to understand the systems that you are interacting with. And what's interesting is that that is a really bad precedent to have from a marketing perspective, because these things are very, very complicated and very difficult to use. And if you're putting first your responsibility as a developer to educate the people that are using your products, you're going to alienate like 99% of that audience. And maybe that's okay. And I'm here from the I don't care about mass adoption perspective. I'm here from the put education first, and the idea is to bring in as many people into your classroom and teach them about the things that you're doing so that they can actually make rational, informed decisions rather than ad-based, influencer-based type decisions. And so with that in mind, this is a slightly more technical talk than the ones that you're probably used to seeing. It's based on a paper that I wrote recently called DeFi's Concentrated Liquidity from Scratch, which you can access at Archive. I've just recently updated it, and there's a corrected version there that I put up just in August of last week. And this QR code will take you there. Now, in order to understand like why I did this and kind of where it's going, we need to kind of go back to first principles. I'm not gonna excuse me. I don't want to assume that anyone is already familiar with what Bancor is and where we've come from and how far we've moved. But essentially, in 2017, Bancor, which was a company in Israel that was experimenting with community currencies. Okay, so this is pre-blockchain world. We had a head of economics, a gentleman by the name of Bernard Litter, who was the gentleman who invented the euro and introduced the euro to European banks. So we have sort of a currency-first approach to things. And these community currencies were working really, really well, except for that when those currencies need to act or interact with economies outside of their own, you need to discover an exchange rate. And this was really, really problematic because community currencies are very illiquid and market makers basically refuse to use them. And so what we wanted was a computer program that can abstract away the need for a human to quote prices and instead quote those prices automatically, and thereby make markets for different community currencies versus each other. And thus, the automatic market maker was born. And with it came things like pool tokens and bonding curves and so on and so forth. And the idea is relatively simple. You have this cylinder shape is representing a liquidity pool, and the brain box above it is representing a smart contract. It's basically saying that all you need is these components, and then any incoming token immediately knows its quote price versus any other token, and so you can exchange them versus each other. You can also be the person who is providing liquidity to keep this thing running. And so we define other parts of the algorithm which knows how to keep account of who is owed what, who has contributed liquidity to this contract, what trades were made, and what is owed back to the people that did it. And these are called the liquidity provider tokens or liquidity pool tokens, which back in the day were known as smart tokens or relay tokens. And so there's two ways that this thing interacts. One is that you're contributing whatever your community currency is to the pool and it's issuing an LP token, or you are giving back your LP token because you're trying to redeem the underlying capital. This is the formula that runs it, okay? And it has been known since back in the day as the Bancor formula, but you may know it more colloquially as constant product market making or CFMM. And there's two main ways that this plays out. The most familiar one is the two-dimensional version, where you've got token balance on both axes and a hyperbola that quotes all valid points between them. But there was nothing in the original white paper or patent for this thing that suggested that only 2 dimensions is allowed. This is just the one that was made popular by developers that I think weren't really grasping the theory as it was originally written. Because you can very easily do this in 3 dimensions or actually any number of dimensions and build like bonding hypersurfaces and things. Now, Balancer did come along a little later and write a much better white paper. But the theory did come from Bancor, and it came from a need to create markets with community currencies. Now, the way that this thing generally operates is that you use this bonding curve or bonding surface or hypersurface to determine all of the allowed token balances. And so what you're allowing people to do is essentially to come in and interact with that system by moving what is the current state of the pool around, thereby achieving exchange. So each one of these arrows is representing a certain number of tokens either coming into or out of the pool, and they're necessarily coupled together. Now, when you abstract some of this into its first derivative, you can actually see the price curves fall out of this quite nicely. And what I wanted to do with this animation, this was prepared for a lecture series that I gave for Token Engineering Academy a few months ago. What I wanted to point out is actually all you need is this component. This is kind of a one-dimensional bonding curve, and you can compose them together any way you like to achieve all kinds of different exchange derivatives. The fact that the most common one is the one where these things are implicitly paired together to create a liquidity pool is a design choice or a marketing choice. The technology isn't contingent on that. So with that out of the way, I want to show you now where amplified or concentrated liquidity came from, what it looks like, and where I'm going with this presentation in general. So the amplified Bancor formula is this. It looks a little bit more frightening than the last one, but I assure you it's not. All we've done is to add this delta term in here, which basically moves the asymptote of that hyperbola into the negative domain. And this means that we can start quoting prices arbitrarily between certain bounds. And you will know this from the concentrated liquidity protocols that have become very popular, where you can basically nominate the 2 price bounds under which your liquidity will remain active. The problem is that the way that it's been described in the white paper literature and the fact that the one that has the presiding dominance in the market today is the one that's been forked over and over and over again, it has obfuscated the fact that there are actually many better algebraic and trigonometric descriptions of concentrated liquidity that developers don't seem to be aware of, and certainly the users don't seem to be aware of. So the transformation that allows you to derive essentially every single description comes from this. If you take the normal pseudo unit hyperbola and twist it 45 degrees, you can create an actual unit hyperbola. And from there, you can start to define this angle, which I'm calling phi. Now, this angle is not the angle that you might be used to on a circle that represents a rotation, but rather the angle that represents an area underneath some curve. So here, theta over 2 is still representing a rotation on the circle, but it's actually this, this area of the sector that better describes theta and generalizes to the case in a hyperbola. So this is still an angle, but it's a hyperbolic angle, not a circular angle. And because of the arc-sinh function is relatively well described across the reals, we can actually use that to compute this angle phi for any hyperbola, and then we can use that as a basis from which all descriptions, algebraic or trigonometric, from which all descriptions of concentrated liquidity arise. And so starting with those principles, and if you go to that archive paper, what I'm showing is that the first description of concentrated liquidity from Bancor in 2020 is literally identical to Uniswap v3's a year later, and is also identical to our new concentrated liquidity description from October of 2022. Now, why would you need 3 different equations if they're all describing the same mathematical object, right? Why are they all doing the same thing And why put so much effort into researching them if they are redundant? The problem is that these shapes that we're using, sure, like in their abstraction algebraically, they work very well. But eventually you're gonna have to represent these using bits in a smart contract. And it depends on what your product is doing that will influence which one of these descriptions you want to use. So for example, with a description like this one, using the geometric mean point of this curve might be very helpful, but in a system like Uniswap v3, where the thing that you're trying to parameterize is the edges of this curve, right? Where the price bounds are starting to exceed the liquidity that you have. That's a much more important price point to, sorry, a much more important parameter to know with high accuracy, because if you fail to calculate it correctly, then what you're going to end up doing is exposing an exploit vector, such as what's happened in Kyber swap and other concentrated liquidity variants. But what's interesting is that when you speak to developers who are trying to build their own concentrated liquidity system, they will just use this system and shoehorn it into whatever product they're building, even if that is introducing exploit vectors with it. In essence, this is the right concentrated liquidity description for Uniswap v3 and for Uniswap v3 only. If you are trying to build something that's more sophisticated or has like a different data structure, it would actually be better to use an equation that takes that data structure as an assumption and then rearranges the algebra in order to make it work. And this is what we did with Carbon DeFi. So again, these these pictures, they are fading in and out, right? The colors are changing, the equations are changing, but you can see that geometrically, it's referring to one and the same shape. It is the same thing underneath. So what can you do with this, right, that you can't do with Uniswap's description? Just quickly, if you want to go back over any of what I've done, right, I had to get through this very, very quickly. I'm running out of breath a little, but I have prepared a lecture series. It's about 5 lecture series long. Each lecture is between 60 and 90 minutes, so it's quite long. But I go through basically all of those steps in the detail required for you to fully internalize it. Unfortunately, in a 30-minute lecture at ETH Warsaw, I can't do that. But that's how we get from constant product to concentrated liquidity in the general case. How do you get from now concentrated liquidity in its infinitely many algebraic descriptions to what I'm calling asymmetric liquidity, which is the first of its kind? Okay, so this is where we get to actually start discussing product. And I'm going to start with a market backtest. So when I first developed the concept of asymmetric liquidity, what I did was to build a market backtesting toy, basically, in Python. And this was the thing that I was using to demonstrate to, let's say, potential customers, institutions, but also my smart contract developers as to what this product is going to do, what my front-end engineers were going to have to try and communicate. And this is the way that I did it. I have a bunch of different price API keys for things like CoinGecko, CoinMarketCap, CryptoCompare, where I can pull any 2 tokens and then compare their price. So let's just go with the BTC ETH price chart. You can actually do this with any pair on our website right now. So if you go to carbondefi.xyz, there is a simulator resource now right there that will allow you to do exactly the experiment that I'm doing here, so you don't feel like you have to take my word for it. If we look at traditional concentrated liquidity, what it's saying is that you can choose any 2 price bounds under which your liquidity will remain active. But because of the way that the algorithm works, you are buying and selling at every price point in here, save for some very, very small delta that we call the fee. But if you were with me at ECC, I've also proved there's no such thing as a fee in an AMM, right? All you have is actually a price spread. So you get a very, very small difference here between your bid and ask, but basically you have to service every single one of these price points as the market moves around inside it. Whereas with asymmetric liquidity, we can actually separate our bids and our asks arbitrarily. We can say, rather than buy and sell in this specific range, I only want to buy in this range, right? When the price of ETH in terms of Bitcoin is in this point, happy to buy. And when the price is getting up here, this is when I want to sell. And this is a much more close to the heart way of market making, right? This is how people think. When someone buys Ethereum at a certain price, they usually have a price point in mind that they want to sell at. And often they will actually just put a limit order in the book on Coinbase or Binance to sell when it gets to that point. Previously, we haven't been able to do that kind of centralized limit order book market making on chain because of the enormous data structures that are required to support it. What's interesting is that when you abstract it into the integral like we have here, the memory footprint isn't just lower than something like Ether Delta. The memory footprint is lower even than a traditional AMM. Right? This, despite the level of apparent sophistication, is actually a smaller smart contract than Uniswap v3. It's also a smaller contract than Uniswap v2. And the gas consumption also drops commensurate with that. Okay, so again, the simulator has a couple of different features, and we can go over that a bit later. Let's just have a look at the dynamics so that I can make clear exactly how it is that we've changed things. This is the ETH BTC chart that we saw before. And we're enumerating prices from 0 to infinity, right? So this is the normal sort of Bancor V1 constant product price market making algorithm. And what I want you to see here is that essentially as the price is moving up and down here, that translates to a left and right motion here. And you can see that the liquidity on the AMM is distributed much the same way you would see it distributed on a book, right? That is the idea behind the AMM. But this is maybe the more familiar representation. So what I've done here is to basically just draw that part of the hyperbola that we're interacting on. And so we're now translating the price point here to the first derivative of this curve. And so what we're looking at is basically as the token balances are moving back and forth commensurate with this, how is the position of our, how is the value of our position improving versus HODL? And you can see, and maybe this is coming no surprise to people who have been around DeFi for a little while, but the value tends to go down, right? And this wasn't necessarily a super volatile pair. The fees that we're accumulating, all right, or really the K growth of this curve is small compared to our exposure. So at its peak, we have a minus 1.5% drop, which is, I guess, pretty significant. But over time, it still trends up. Right? You should be able to see, if you were to just draw a straight line from here to here, there's still a very slight positive trend on it. And this is generally where AMM performance should come from. Very, very long, well-sustained uptrends, but for tokens that have a high volatility response with respect to each other, but trend sideways. So we can summarize these kinds of positions like this, where the blue line here is representing the portfolio value in terms of the AMM, and the gold line is representing the HODL position, had you not decided to contribute liquidity with it. So whenever the blue line is above the gold line, this is your impermanent gain, if you want to think of it like that. And whenever the blue line is beneath the gold line, like it is over here, that's your impermanent loss. Now, concentrated liquidity was originally marketed by Uniswap as being like a decent answer to impermanent loss. We're going to find out if that's true. So we're using our the same methods that we were to interrogate the constant product case. And what you should be able to see is that the price is kind of leaping around, and you can see it leaving a very small gap, right? That's that effective fee level that, that you charge on a Uniswap pool. And we're letting those fees accumulate over here. Now, importantly, as our asking prices are being taken, it's still being filled with bid prices immediately behind it. And you can see that represented here as well. And when the price comes back down, you'll see that those bidding prices are replaced by asking prices. But once the price moves above or below that band, we've effectively run out of liquidity, and the thing basically stalls. Now, we can still draw that hyperbola, except now it's a much more zoomed up version, because on the constant product case, it asymptotically approaches zero in either axis, but this case, it actually strikes zero. Now you can see here, and I want you to pay attention to this on this animation because we're about to have a look at asymmetric liquidity. But what I've done is to label the ETH balance on the Y and the BTC balance on the X on the left chart. And on the right chart, I've got the BTC balance on the Y and the ETH balance on the X. Now, when this price starts falling back through this region, what I want you to just pay attention to is that they respond symmetrically, right? And that shouldn't be too surprising because this is just the transpose. But they are responding the same way, right? They are one and the same price quoting algorithm. Now, a lot more noise here. So you can see that with concentrated liquidity, it's a lot more sensitive to things that are happening inside it. So for example, we have a very large amount of impermanent loss way back here when the price is moving outside of our range. But overall, it trended quite high. And this position actually is more profitable than the standard constant product position, but it didn't come without cost because this drawdown that we had early on in this simulation is quite significant. Okay, what about asymmetric liquidity? So this is the one that comes with Bancor's new product that we call Carbon. This is not a mistake, it's an anagram of the word Bancor. It's meant to represent kind of a new perspective on market making. So let's have a look at those exact same animations now. Because our bids and our asks, they're still linked together, but they're not necessarily dependent on each other. When the price comes down through our bids, rather than the asking prices continuing to chase the market down, it stays where it is. And so again, this is a design choice. As our asking prices are taken, we're still converting our base asset to cash asset, but the asking prices do not continue to chase the market up, which is another way of saying that this protocol allows you to wait for better prices. It allows you to wait for cheaper prices to buy, and it allows you to wait for higher prices before selling. Now, on the invariant function graph, we can see, unlike before, these are not the transpose of each other. The ETH balance has its very own bonding curve, and the BTC balance has its very own bonding curve. And I've labeled the X axis on both of these as a fictional X coordinate, because this is really just the shadow of performing an integration across the price curve. Now, the performance versus HODL is much, much better, right? This is actually giving you, and we can see in the next chart here, a dramatically improved portfolio performance profile versus either concentrated liquidity or constant product. And the simulator quantifies it, right? If you want the code for this, I have it in Python. So if you want to audit this yourself, I'm very happy to do that. But these results really do speak for themselves. So if we're using constant product from 2017, that exact heads-up comparison gives a 1% profit for the 2017 technology, 14% profit for 2020, and for Carbon DeFi, which is from 2022, about a 37% profit, which is pretty interesting. Now you might think that I've cherry-picked this, but actually I chose this because I think it's the one that you might find more believable. Because of this ability to set arbitrary bids and asks, you can create ridiculously high returns on this. So you didn't want to, I could very easily have chosen a backtesting period that would produce stupid APYs like the ones we're used to seeing in DeFi. But what I've tried to do is to choose one that I think has a pretty decent heads-up comparison. So yeah, that's the product. It's Carbon DeFi. It is the new generation of concentrated liquidity protocols. If you want to know more about this, this is the website where you can access it. This is the simulator. And if you want to, you can reach me at any of these destinations. So thank you so much for your time. I've tried my best to get through it without contributing too much to the how much we're running over. But I'd be very happy to accept any questions, and thank you for your attention.
Massive round of applause for Mark, guys. Yes, we do have time for questions, and thank you for going through so swiftly, by the way. And I had no idea Carbon was an anagram for a banker, and I've been using it. Please, question, guys. Who's up for the first question for Mark here?
Thank you for your presentation. My question, very quickly, do you think the API will be decreasing over the years as just the 2017 and the other numbers that you showed us will? Because
it's a really good question. So the question is, do I think that the API using this product is going to trend down over the years? Yes and no. As volatility between various cryptocurrencies continues to like tighten, then yes, the ability to trade against that volatility and earn a profit is going to tighten with it. That's another way of saying that the margins are going to become diminishing over time. But it still comes down to the skill of the trader. So for example, for things like ETH and BTC, let's say 20 years from now, there might just be like free floating, currencies, and they have like a very, very minor volatility. Like Bitcoin's basically just approached the asymptote and settled on whatever price it's settled on. ETH is settled on whatever price it's settled on. And now trading between them, you're trading like basis points. You're not going to be able to get, a return like that. But that doesn't mean that someone very cleverly has released a new meme token on Solana or something, and then created a competing meme token on Ethereum and is like bridging them to create more volatility or something like that. The point is that the product is only as good as the person who's using it. You need to make these decisions. These are the prices that I'm selling and buying at. The protocol doesn't prescribe that for you. So I think my perspective is that people will actually get better at using these kinds of tools over time. And so I think the APYs will increase slowly, but they should stabilize and then eventually trend down as volatility trends down.
Any other questions there, guys? Got time for one more? I love it. Straight in.
So I'm sorry because I wasn't here since the beginning, but so you said this protocol is as good as the trader. So there is no option to really like automatically set up the most optimized, I would say, way to do it, because I assume also if everybody would do it, then they would lose on the effectivity too, right?
Yeah, correct. There's no automated way to do it at the contract level, because this would require things like Oracle price feeds and other like third-party dependencies that add like a lot of, let's say, attack surface area that we're not really happy with. So the contracts are bare bones. Having said that, that doesn't mean that you can't use your own like off-chain API or something to modify your position over time according to whatever signals and things that you want to use. So for example, one of the institutions that I was speaking with is using a like momentum indicator to trade Ethereum. And they like this product a lot because they don't like spot trading on chain because of sandwich attacks and other things. And this is sandwich attack immune. And so what you can do is say, wait for the momentum indicator to hit and then quote a price on chain and wait for it to be taken. Now that price quoting component doesn't know about why you quoted that price. So the automation is on the user, right? If you want to automate it, go right ahead, but it's not built into the product and it never will be.
Amazing. Another massive round of applause for Mark there, guys.